Today we're going to continue our talk on consecutive integers, except now we're going to be doing consecutive even or odd integers. And all that happens by going consecutive even or odd is we're changing the pattern. Yesterday's pattern was a +1 pattern because if I'm at 6 and I want to get to the next integer, I have to add 1 to get to 7, and add 1 to that to get to 8, add 1 to get to 9, and so on. Well, odd numbers, I'm going up 2 at a time. If I'm at 1, if I add 2, I end up at 3, the next odd number. If I add 2 to that, I end up at 5, the next odd number. Add 2 to that, I get 7, the next odd number, and so on. If I'm in even number world, if I'm at number 2, and I want to add 2 to get to the next even number 4, add 2 to get the next even number 6, add 2 to get the next even number 8, regardless of odd or even, they have the same pattern. So algebraically, whether it says even or odd, we're applying a +2 pattern to this. So it's n plus 2, n plus 4, n plus 6. Okay, a lot of students have difficulty believing that. I know this because I see a lot of students work and they don't put down that on their paper when it says consecutive odd integers. All right, here's how it works. Okay, algebraically, these represent our numbers, right? Odd or even. Okay. What makes this different if it's odd or even is what n represents itself. If n represents an even number, Parker, pick an even number. 4. If n represents the number 4, I add 2, I'm going to get 6. I add 4, I get 8. I add 6, I get 10, right? So I'm creating a list of even numbers. Hannah, pick an odd number. 3. If n represents an odd number 3, 3 plus 2 is 5, 3 plus 4 is 7, 3 plus 6 is 9. By changing what n represents, but applying the same pattern, I'm going to create either a list of odd numbers or even numbers. So regardless of either one of these two adjectives, even or odd, this is what they look like algebraically. This is how we're going to set up our unknowns. So if we look at example 1, it says find 3 consecutive even integers. So again, I see the words consecutive integers, I immediately know it's this kind of problem. I see the adjective even, that tells me that it's going to be an unknown setup of the first number n representing some even number, because we're looking for even integers. The next even number is going to be 2 bigger than that. The next one's going to be 2 bigger than that. It says find 3, so I only have to list 3. If it said find 4, I'd want to include n plus 6. All right? Just like yesterday, the words such that mean that an equation is about to start. The equation writing here says the sum of the first and second. So we're supposed to add the first and the second equals, that means equal sign, the sum of, there's the word and, we're adding the third, which is this, to negative 10. So that's n plus 4 the third plus negative 10. So again, you create the equation from the words, being careful in the equation writing that you write down exactly what you're supposed to do. If I combine like terms on both sides, on this left-hand side here, all I can make is 2n plus 2. On the right-hand side, 4 and negative 10, so 4 plus negative 10 makes minus 6. The n doesn't have any like term with it on the right-hand side. And at this point, I've got letters on both sides, numbers on both sides. I'm going to move the n to the left. I'll move the 2 to the right. 2n minus 1n makes 1n. Negative 6 minus 2, they're both the same sign, so I add. 6 is bigger, so it's negative. What kind of number is that, odd or even? Even. It says find even integers. So the fact that I found an even integer gives me a little bit of feeling that probably I did something good there. Okay? And it does say find 3, so negative 8 is the first one. I'm going to add 2. So negative 8 plus 2 is negative 6, and negative 8 plus 4 is going to be negative 4. And just like yesterday with the negative solution, make sure you are adding these numbers. Adding to a negative actually subtracts the values. So make sure you go the right direction when you get negative answers.